Sam is learning about cycles in science class. Today, his teacher introduced the water cycle. As Sam helps his mom prepare dinner, he realizes that he is seeing the water cycle in action in his own kitchen. There are some parts of the water cycle in this picture. Click on the highlighted areas to see them up close. When done, click the next button to discover even more about the water cycle and to learn why it is so important to life on Earth. Sam learned in science that the water cycle describes the way that water on Earth is in constant motion. As he picks up his glass of ice water, Sam feels that the outside of the glass is wet. This is because water from the air has touched the cold outside surface of the glass. Do you know how this happens? Sam learned in science. When Sam looks out the window, he notices that it has started to rain. This is another step in the water cycle. Sam knows that rain comes from clouds, but how does this happen, and why? Sam stirs some rice into the pot of boiling water. The water level in the pot has gone down a little. Some of the water has evaporated from the pot. Sam wonders where it has gone, but then he remembers his lesson from earlier. Can you think where the water may have gone? Welcome to the lesson, What is the Water Cycle?, where you'll learn about the importance of water and how water cycles from Earth to the clouds and back to Earth. The vocabulary words for this lesson are water cycle, evaporation, condensation, precipitation, runoff, and atmosphere. Click the words to find out more about them. Think of an organism, any organism. No matter which one you've got in mind, it needs water. That's because all life on Earth needs water to survive. Although there seems to be plenty of water on Earth, most of it is salt water. In fact, only about 1% of Earth's water is fresh. Let's take a closer look at how water is present on Earth. Click the labeled spots on the circle graph. 1% of all the water on Earth is fresh water found in lakes, streams, rivers, and other bodies of water. Humans and other life forms depend on these sources to meet their needs. Look how much of Earth's surface is covered with oceans. The oceans make up 97% of the water found on Earth, but it's salt water, which is not suitable for drinking by land-based organisms. Most organisms need fresh water to live. In some countries where fresh water is scarce, salt water is processed to create drinkable fresh water. 2% of all the water on Earth is located in remote glaciers or deep underground. This water is fresh, but it is not easily available to be used for drinking water or irrigating crops. The water cycle has no real beginning or end. But let's pick a part of the cycle and begin our exploration there. Click the pictures to discover how the processes of evaporation and condensation keep water circling through our atmosphere. Evaporation is a process by which liquid becomes a gas. For water, this gas is water vapor, which you can't see. When the sun warms water in the oceans and other bodies of water, it evaporates into the atmosphere from the surface. Water can evaporate quickly or slowly. High wind speeds and high temperatures speed up evaporation. Cool temperatures and low wind speeds slow down evaporation. Water on Earth is stored in icy glaciers, oceans, lakes, and rivers. As we discovered earlier, only a small percentage of this is fresh water and available for use by organisms living on land. Once it evaporates, water is stored in the atmosphere. This water vapor can be transported by winds over long distances before it forms clouds and falls back to Earth as rain or snow. So ocean water could end up falling as freshwater rain on your roof. Clouds are formed when vapor condenses. As vapor rises in the atmosphere, it cools to form clouds. These clouds may produce precipitation, such as rain, snow, sleet, or hail. It becomes vapor and eventually condenses into clouds. Can you remember what happens next? Click the images to find out and discover a little more about how this happens. Like most things, air can hold only so much water. When air reaches its limit, water vapor condenses or freezes to form clouds. When the water droplets or snow crystals in a cloud get too large, they fall to Earth as precipitation. Depending on the air temperature, this precipitation might reach Earth's surface as rain, snow, or even freezing rain. Precipitation that doesn't sink in or evaporate is called runoff. It flows downhill into rivers and streams, and eventually to the ocean. When the sun warms the oceans, lakes, and streams, water evaporates into the atmosphere. And, you guessed it, the cycle begins again. Did you know that right this second, the water cycle is happening all around you? It doesn't happen only in certain hot and wet areas, but all over the planet, everywhere, and all the time. Let's look a little more closely at how this occurs. Click the labeled spots to see how water constantly moves between Earth and its atmosphere. The sun heats up surface water and it evaporates into the atmosphere. As most of Earth's water is held in oceans, most evaporation takes place from the oceans. It's strange to think that clouds are actually clumps or collections of liquid water, but they are. Clouds are caused by water vapor rising into the atmosphere, where it cools. When this happens, it turns to liquid form and condenses into clouds. Clouds float because they are less dense than air. When tiny water droplets clump together, eventually they become large enough to fall back to Earth as precipitation. If the air is cold enough, water vapor changes directly to ice, and you get snow. Precipitation can either seep underground or become runoff. Water that seeps through the ground is called groundwater, and it can wind up in an aquifer. Runoff eventually returns to oceans through streams and rivers. Now that you're aware of the components of the water cycle, you can see that what goes up as evaporated water vapor must pour down as cleansing and cooling rain. Without both these phenomena, life as we know it simply wouldn't function. Let's see if you know the flow. The flow of the water cycle, that is. Match the definition with the vocabulary word. Drag and drop to match your answer. Imagine that all of Earth's water runoff were diverted into underground reservoirs and the seas disappeared. Sounds like a real problem. Describe what you think might happen. Do you think the water cycle would stop? Type your answer in the space below. Click OK when you're done. Well, with all the water held underground and hidden away from the effects of the sun and the wind, evaporation would stop. It's likely, then, that the water cycle would eventually stop. You'd better keep a bottle in your fridge. You've learned a lot about how the water cycle moves water throughout Earth and its atmosphere. Let's take a quick look at some key concepts. You've discovered that the sun's energy drives the whole water cycle. And thanks to solar energy, we have a continuous source of fresh water. The water cycle has 4 parts: evaporation, condensation, precipitation, and runoff or groundwater. All parts depend on each other. The water cycle has no beginning or end. Each step sets the next step in motion. Fresh water is being recycled all the time, all around you. Now that you've finished this lesson, if you wish, you can go